This summer we're going to be doing a bunch of NASA camps. Now NASA, as you know, is our North American space program. National Aeronautics and Space Administration, I believe, is what NASA stands for. We've also been talking a lot about temperature, and how temperature is quite relative. Well, what I have with me here today is our NASA galactic thermometer right here. Galactic thermometer. And we're going to talk about some different temperatures and how they relay out into outer space and then coming all the way back to planet Earth and some of the coldest places on planet Earth and definitely some of the hottest places on planet Earth too. So the coldest temperature out there is absolute zero. Absolute zero. But what's really close to that is a fluid version of the gas that is helium. Superfluid helium is coming in at a temperature of about negative 456 degrees Fahrenheit. It's about the coldest substance that we really know of out in outer space. Now, speaking of outer space, let's just say you're floating around in deep space. Well, that'd be pretty cold too. That's coming in at about negative 455 degrees over here. Now, getting into talking about some of the specific planets in our specific solar system. We have the wonderful ringed planet known as Saturn that comes in at about negative 229 degrees. The rings around Saturn, some people might not know, is basically just orbital space dust that has formed its own orbit around Saturn. Now, coming in just a little warmer than Saturn is the planet that we most recently sent our Perseverance rover to, which is good old red planet of Mars. Funny thing about that Perseverance, there's about an 8 to 10 minute loss of time they had when the Perseverance rover entered into the Mars atmosphere. So for about 8 to 10 minutes, all those scientists that had been working decades and decades to build this rover they weren't even sure if it was going to survive going through the Martian atmosphere and being able to successfully land. So when that 10 minutes went by and they found out that their Perseverance had landed safely, they cheered and partied like never before. All right, moving on to some other temperatures here. We got, let's see here, good old, I believe, Antarctica. Once we get into our planet Earth here, it's about negative 30 or so. It's pretty chilly. Now that's negative 30, but then that's about 1.5 times colder than your freezer. And the coldest temperature ever recorded in Antarctica was negative 128 degrees. Super cold. Now moving on. Let's say we're talking about different temperatures that are starting to get to where we can freeze H2O. That's going to be about 32 degrees Fahrenheit right over here. Then we start to get up into average room temperature as well. And that average room temperature is usually about 68 degrees to 70 degrees or so. Then we talk about the temperature of our good old human body. We talked about it earlier, usually averaging somewhere right in between 97 and 98 degrees, average temperature being 98.6 degrees. Then we talk about the hottest place on our planet Earth. Now we know the coldest place is Antarctica, but the hottest place is the Sahara Desert that has reached temperatures of 136 degrees before. And then Let's say we're going to take H2O, good old water, and instead of freezing it, we change it into a gas and we boil it. Well, you have to get that all the way up to 212 degrees. So in this galactic thermometer right here, we're going all the way from the depths of fluid helium being negative 456 degrees to boiling water coming in at 212 degrees. Now, besides that, if you're an astronaut and you're living in outer space, there's definitely some things that you got to do differently. You don't have the gravitational pull coming down on you, right? You have to be able to...
I'm chasing you.
Yeah,
I'm chasing
you are.
Rob. You and me, I'm going up, you're going down. It's hard to tell which one of us is going the right way.
Yeah, story of my life. Anyways, let's say you're an astronaut and you're out in one of our space shuttles, or you're out at the International Space Station and you're going to eat your food. Well, you can't have food that's going to crumble or anything like that. There's no cookies in outer space. You got to have food that can be strapped down. Because let's say you start to get some cookies crumbling and these crumbles go flying over into your computer and that starts to make things malfunction. That could be super duper dangerous for everybody involved. Also, obviously, outer space food has to be a little bit different too. It has to be very compact and very nourishable as well. If you look carefully, all these pieces of food are basically strapped down. Now, hygiene in outer space as well. You're in close contact with your fellow astronauts. You want to make sure that you can have a good level of hygiene. But you can't have a bunch of water going around to wash your hair with. In this case, obviously, Radical Rob wouldn't have to worry about that at all. But these guys basically use a shampoo that you would just rub into your head and then you would comb out. Let's say you want to have some downtime. You're going to have quite a bit of downtime in outer space. So a lot of the astronauts, maybe they'll like to play a musical instrument. You can see this gal and her flute, and you can see she is strapped down, as is her music that she's looking at too. This guy over here playing chess, he's got Velcro pieces on his chess pieces so they don't go flying around. But let's say you do want to fly around like Superman. These guys are totally using anti-gravity to just cruise around like the Man of Steel himself. And then, of course, going to the bathroom. Obviously, you want to make sure that when you're going to the bathroom in outer space, you are strapped in, and you want to make sure that anything that goes into your space toilet basically has a vacuum to pull it in really quick. Because as you can imagine, you start to be dealing with anti-gravity and people going to the bathroom, things could get really dirty. And then sleeping. Astronauts, they don't want to be just floating around, bumping into things when they're sleeping. They got to be strapped down too. You can see this guy strapped to the side. And then you see this guy strapped down too to live in space. Now, another really kind of fun fact too about outer space, because there's no gravity, your astronaut in an average space mission, their spine will actually grow about 2 inches while they're out in outer space. And that's because, like I said, no gravity, no atmospheric pressure coming down on them at 14.7 pounds per square inch. So I can actually demonstrate that using my 2 little balloon buddies. This is Ray, and this is Ray's brother. His name is Raymond. Ray and Raymond. They're going to go into outer space, into this little pressurized thing. They're going to start to get the gravity taken out of this little pressurized rocket, like so. Watch carefully and see what Ray and Raymond start to do. Just like an astronaut in outer space, they're going to start to grow because there's no pressure, there's no atmospheric pressure or gravity pushing down on them like there is on the planet Earth. It's really important that astronauts actually constantly exercise or work out when they're up in outer space, or else their muscles will become what's called atrophied because they don't have enough pressure on them. So we got Ray and Raymond. If you look in here, they pretty much filled up the canister right here.
Wow.
What's going to happen when we add gravity back into it? I'll squeeze. And there they go. They release back to their old selves. Ray and Raymond, everybody.